Well, let's see, can we take another method and create a few Pythagorean triples? Okay, welcome back to the Pythagorean theorem and the last video on these Pythagorean triples, which I really feel is a good thing to know, but that's my take. Anyway, it is easy to construct these Pythagorean triples when m and n are only, any two positive integers. So let's take a look at the formula that is used to do this, and I can say that a, remember, is a squared plus b squared is equal to c squared. We would say it's equal to n squared minus m squared. That's how we would get a, and then we said we can get b by using the formula 2 times n times m, and we can get c by using the formula n squared plus m squared. Okay, so let's see, can we construct the very first Pythagorean triple by using, so I'll just say example here, and I want to use m is equal to 1, and let's use n is equal to 2. That follows what we say here? Yes, it does, because m is less than n. Okay, so let's go on and see, can we find what is a. So a will equal to n squared, which is 2 squared, minus m squared. Let's go ahead and just substitute while we're here so we don't run out of room here trying to get this together. So this will be 2 squared minus 1 squared. And if we go on and square 4, so here a will equal to 4 minus 1, and then we see that a is going to equal to 3. Well, that looks okay. We'll get there. We'll see if we're going to create this very first triple using this format. So now let's take a look at what it says to use for b. So it says b is 2 times n, which is 2, times m, which is 1. So 2 times 2 is 4, times 1 is 4. So b is equal to 4. Okay, so let's make sure we identify whether we're doing the right thing for these triples. So then it says to find c, we will take n squared plus m squared, which is 2 squared plus 1 squared. That's going to give us 4 plus 1, which indeed equals to 5. So guess what? As I look at my answers using this formula, we have the triple of 3, 4, and 5. Let's take a quick look and see what can we do if we have. Okay, make sure we don't get in the way here. So if I have m as 2 and n as 3, again, I'm looking so that m must be less than n, and that fulfills that requirement. So as I go on, my very first one will be 3 squared. I'm looking for a, so I see 3 squared minus and I'm looking at 2 squared. That's going to give me 9 minus 4, which equals to 5. So we're saying that 5 is our first number in this particular triple. So let's take a look and see how we find B. So it says B is equal to 2 times n is 3 and m is 2. So here I'm looking at 2 times 3, which is 6, times 2, which is 12. Okay. Now let's take a look at C and see how will we find C. And here C is going to be n squared minus, so n is 3 squared, and actually that's plus 2 squared. So that's going to give us 9 plus 4, and that equals to 13. So that is telling me my second triple that I've just created using the numbers going down the line will be 5, 12, and 13. And that is indeed our second triple on our list if you go back up. So pretty interesting, I think. Pretty interesting, and it's a pretty interesting way to find these triples if you just have that love and taste for Pythagorean. So have fun constructing your own triples.